All right, so 11.5 is called Sums of Arithmetic and Geometric Sequences. And so the first thing we need to talk about is something called a series. So series is kind of like the sequences, but instead of just them being listed, you're going to be adding them together. All right, that's what's going to make it a series, not a sequence. All right, so here's the example for arithmetic sequence versus an arithmetic series. So sequence, you're going to see they just list 3, 7, 11, 15, 19. And then for a series, you're going to add 3 plus 7 plus 11 plus 15 plus 19. And this one's considered finite because it stops. It's a limited amount of numbers. And then geometric, same thing. Sequence is going to be the list, 1/2, 1/4, 1/8, 1/16. And then when you have that ... that means it's going to go on, it's infinite. And then series, obviously, you're going to add 1/2 plus 1/4 plus 1/8 plus 1/16. All right, so we're going to get a fancy new way to write this. We're going to use the Greek letter sigma. How many of you watched the Ed Puzzle video? Okay. Did it have this? Oh. Oh, okay. So, what's an Ed Puzzle, right? Yeah. So this is what we call the summation sign. It's the Greek letter sigma. It kind of looks like a capital letter E with these funny little things coming in. And so let's look at an example and see what they want us to do with this. All right. So first of all, you're going to notice that it's a series, right? Because we're adding 2 plus 4 plus 6 plus 8 plus all these bunch of numbers in here all the way up to 100. Okay? So from the first number in the series to the next number in the series to the third number in the series to the fourth number in the series, does anybody recognize what the pattern is? What? You would add 2 each time, right? Or if it's the first number, if it's the first one, you would say times 2. So 1 times 2 would get you 2. 2 times 2 would get you 4. 2 times 3 would get you 6. 2 times 4 would get you 8. Okay? So we're going to list it as 2n. And we started with 1. So that's the number you put down here. You say n equals 1. How many times are we going to do it to get to 100? 2 times what, basically, is 100? 50. And so if you were going to read this, you would say the sum of 2n for values of n from 1 to 50. And so we're going to try another easy one, just like that. So example number 2. Again, we've got a series. We've got the first one, the first term is 1, and then 4, and then 9. We've got some numbers in here ending with 100. Anybody recognize the pattern that's going on here? Yes, sir. Squaring, right? 1 squared is, 2 squared is, 3 squared is, right, okay. And 100 is what number being squared? 10. So we're going to, and notice here they use the variable n, and here they're using the variable k. So you can switch that variable around. So we're going to say k squared. And this time we're only going from 1 to what? 10. So you're going to, if you were going to read this, you would say the sum of k squared for values from 1 to 10. Okay, and that's kind of what you need to know about series. Okay, the next thing, I'm going to move this up. You'll see it in just a second. So you're still copying it. Okay. So the next thing we're going to talk about is Theorem 1, and Theorem 1 is for the arithmetic series. And here's the equation. Put that down just so see it. So the first equation is the theorem, and then underneath it I just wrote what each part means. Okay, so the S sub n is just going to be the sum of the nth amount of terms. So n is just going to be the number, right? T1 is going to be term 1, or whatever the value of the first term is. And then T sub n is going to be the value of that nth term. Sorry. And so there's 2 steps that you need to do in order to get the sum of the arithmetic series. Okay. First of all, you're going to need to use the arithmetic sequence formula to find the nth term. Okay, that's the one we used last week. We used the arithmetic sequence formula. We figured out whatever the value of whatever term they told us to figure out. And you guys got pretty good at that. That's what you did on that worksheet. Okay? So that's the first thing. Once you've got that number, you'll need that number to plug it into Theorem 1. Sounds kind of complicated, but it's really just plugging in a bunch of numbers. All right. So example number 3, and I need to move this up just a tad so you can see that a little better. Example number 3. We're going to find the sum of the first 40 terms of the arithmetic series. Okay, so we're going to do step number 1, which says to use the arithmetic sequence formula first, which was T sum n, the first number in the series plus your n minus 1, times whatever the D is. Okay? Who remembers how to find the D? Jaden. Right, in this case, we're just, yeah. So each time we're just adding 3, right? So from 2 to 5, I didn't leave myself enough space. So from 2 to 5, we add 3. From 5 to 8, we're adding 3. From 8 to 11, we're adding 3. So that's our D, right? And then the question tells us we want the 40th term, right? So that's what we're going to use first. We're going to say the 40th term is going to be equal to the first term, which is 2, plus, and then we have to plug in 40 for n, so 40 minus 1, times the D, which we just figured out, times 30. And at this point, you can just plug it in your calculator. 40 minus 1 is what? 39, and 39 times 3 is 117, and then you add 2. So the 40th term is 119. Okay? So do that on your calculator. Or if you're really smart, do it in your head. Okay? We need that number. That number is going to go into our Theorem 1 formula. Okay? So the Theorem 1 formula says S sub n equals n times t sub 1 plus t sub n, all divided by 2. Okay? So we want the sum of the first 40 terms. So we're going to say S sub 40. The n is the 40, because we want the 40th term, times the first term, which is still 2. It was 2 right here. It's still going to be 2 right here, plus the number that we just got, the 119, divided by 2. And again, you want to take your calculator, punch that all in. So 2 plus 119 is going to give you 121. Multiply 121 times 40, and then divide it by 2. I got, what did I get? 2,420.